In question 3, Tanya is going on holiday to Cypern and is interested to find out what is happening to the weather in the 8 weeks over the summer before she goes. So she has summarized her results here, sigma x and sigma x squared, where x is the weekly rainfall, and we are asked to find the standard deviation. The standard deviation is the square root of the variance, so we can start by working out the variance, which is the mean of the squares minus the square of the mean, and we can see that we've been given up here sigma x and sigma x squared, so if we just substitute that in, that's going to give us 985.88 divided by 8 minus 86.8 divided by 8 all squared. And if we do that, we get an answer for the variance of 5.5125. So if we take the square root of that, we'll have the standard deviation, which is going to give us an answer of 2.35. In part B, we're also told that Tanya decides to measure the hours of sunshine per week at her holiday destination, and that is denoted by y. And we're provided with information on the mean of y, the standard deviation of y, and sigma xy, and we're asked to show that SYY equals 716, correct to 3 significant figures. Now, you might recall that SXY is what we call the covariance, and you might therefore assume that SYY is the variance of y. Now, it is related to the variance of y, however, it is not itself the variance. So when we are looking at variance, one way we could express the variance for y would be to say that the variance of y is equal to sigma y minus y bar squared over n. Now, when we're looking at correlation, we replace the numerator here with different terminology, which is s, y, y. So it's the same concept, but when we're looking at correlation, we call it s, y, y. So that's going to be s, y, y over n is equal to the variance of y. So we're asked to show that SYY equals 716. So if we rearrange this equation here, we can have that SYY is equal to the variance of y multiplied by n. In the question, we are given information on the standard deviation of y. So the variance, therefore, is going to be 9.461 squared. And if we multiply that by the number of weeks which she's recording data for, which is 8, we will get our final answer of 716, correct to 3 significant figures. In part C, we're asked to find the covariance SXY. So in this instance, all we need to do is substitute the information we've got into the formula. So sigma xy is equal to 4,900.5. But then things start to get a little tricky because we are supposed to find the product of sigma x and sigma y divided by n. Now we've got sigma x here, but we don't actually have sigma y. Now, we could work backwards and use the mean to find sigma y, but if you think about this section of the formula here, sigma x, sigma y over n, we can actually rewrite this as sigma x times sigma y over n. If we multiply out, that's going to give us the same thing. And we've said that this, therefore, is y bar. So we could just write this formula here as sigma x, which is 86.8, multiplied by y bar, which is 58. And if we do that, we end up with an answer of negative 133.9. We've been given a lot of information in this question, and we've also calculated a lot as well in the earlier parts of this question. We've now got to put it all together in order to work out the product moment correlation coefficient R for this data. So again, this is really a question of just throwing the numbers into the formula. So this is going to be xy over the square root of sx sy. Now, some of this we can put in straight away. So we found previously that the covariance was going to be negative 133.9. And then we want to divide by the square root of sxx. Now, we haven't actually worked that out, but in the same way that we worked out syy, we've got up here, or in our answer to the first part A, we were asked to work out the standard deviation. So we've got the standard deviation. So from that we can work out the variance of x, and we should remember that the variance is related to the value of sxx using the formula variance equals sxx over n. So therefore, if we want to find the value of sxx, we're just going to take the variance, which is going to be 2.35 squared, and multiply that by n, which is 8. We then need to multiply that by syy, which we have already found to be 716. And if we calculate that, we end up with a value for R of negative 0.753. In the final part then, we're told that during Tanya's holiday there are 14 millimetres of rain, 70 hours of sunshine. And then we're asked to state, giving a reason, what the effect of adding this information to the above data would be on the value of R. So R is quite a strong negative relationship, something like this, which is suggesting that the greater the value of X, which is the rainfall, the lower the sunshine. Now, what we can see in the additional evidence that we have from Tanya is that we've got a smaller amount of rain and a higher amount of sunshine. So this would appear to be at odds with the data from which the model is generated, so therefore would weaken the relationship and therefore would reduce the value of R.